Hi, my name is Brayan Ortega. I thank TKS for giving me the opportunity to apply for part of the scholarship. For the research study, I've decided to focus on Microsoft to explore the topic of efficiency in data centers, climatic change and data center. In recent years, the issue of rising temperatures has become increasingly alarming, as we can see in the chart. From the years 2000 to 2020, carbon consumption has increased across all industries. Furthermore, with the rise of artificial intelligence, especially since 2010, this is now generating a prominent crisis. As the use of AI continues to grow, it will drive the need for more data center infrastructure and consequently a significant increase in electricity consumption. In this other chart, we can see, for example, that a Google search, as it used to be done, consumed around 0.3 watts per hour. Now, that same search, when performed using ChatGPT, can consume up to 3 watts per hour. This is alarming. If today there are hot zones within the data center, by 2050 it will be catastrophic. Therefore, it is necessary maximize efficiency and reduce carbon footprint. Possible targets: reduce energy consumption, improve air conditioning, localized cooling with refrigeration, design a new room layout. Designing solutions. If my career vision is architecture and design, showing light of this current real issue of climatic change and the need to reduce carbon footprint from data centers, my proposal is related to a change in design, but this proposal will generate a need for new ways of doing things. So I started researching more about how data centers work and how they are designed. I found that they are like large rooms filled with organized cabinets, and in some cases, there are even closed-in island-like structures with a cold air distribution system that returns the hot air to improve energy use and efficiency. But I identified a problem. This problem was related to the fact that since the cabinet was completely enclosed, the equipment at the bottom, which generates heat, will transfer that heat upward to the equipment above it. As a result, the heat will accumulate progressively, with each level adding more heat to the one above. This means that the temperature at the top becomes much more chaotic than at the bottom. This rectangular shape of the cabinet, along with the internal heat build-up, leads to the formation of hot spots inside the cabinet. This causes an increased use of air conditioning in an attempt to cool down these hot spots, which is not energy efficient. That's why I want to share the inspiration I got from my trip to Cusco. During this trip, I saw a series of agricultural terraces in the highlands that had different microclimates. It was based on the shape and structure of these terraces that I developed the following idea: a staircase-shaped cabinet, which prevents heat from accumulating from bottom to the top, allowing, allowing the temperature to dissipate more effectively. Just like in microclimates of the terraces, where each step has a different climate, this new cabinet design aims to ensure that each step can dissipate heat independently. This staircase-shaped cabinet design also allows access to the internal equipment, as shown by the red arrow. The equipment is positioned in a way that allows it to slide out for easy access, enabling personnel to handle the devices inside more efficiently. The image. This is a reference for how the proposed cabinet will look. With this new design, the airflow will enter more evenly across each level of the equipment. In this way, the heat generated by the devices will also be dissipated more uniformly, and hot spots will no longer form inside the cabinet. As shown in the image, at each step of the staircase, the temperature realized by the equipment will be evenly distributed at every level. Finally, this cabinet design, which I call Inca antennas or Inca terrace, will also allow for separating the cold environment from the hot one, as shown in this figure. Now, we can have one staircase aligned next to another, or two staircases facing each other, forming a kind of truncated pyramid. In this setup, the cold airflow will enter more evenly into each piece of equipment inside the cabinet, and the hot air will be dissipated more evenly. This will lead to greater energy efficiency, as the cooling system will require less intensity, given that the cabinets will no longer generate hot spots. And this will contribute to better temperature control, reduce electricity consumption, and less reliance on air conditioning. As a result, there will be lower energy use and a smaller environmental impact in terms of carbon footprint. With a simple design variation, it is possible to address the current issue and in turn help meet the growing demand brought by the rise of AI. Thank you.